I want this video to highlight what can be done with the mirror facility. So that's using the mirror in a sketch to make linked face associations in the model. These can be very useful for the easy creation and further manipulation of symmetrical features within a part, or even the making of two mirror or mirror similar parts. Once created, these relationships, these linked face associations, are owned by the body as in a feature symmetry situation, or, in the case of a handed body pair, by the owning body's component. There's no structure browser mirror icons to interact with, but by just mouse hovering over a face, linked faces texture highlight, and upon selection, the corresponding mirror plane is displayed. So this is a very visual way to confirm a modification change and get a quick result. For example, by a single face selection, you can see the other linked faces changed to a textured highlight. It's noticeable in the solid view as well. For instance, if I click this face, again, you can just about see a texturing of faces. Whilst I'm talking about the advantages of using linked associated faces in mirror planes for the easy manipulation of symmetrical features, there's another feature which isn't particularly well documented, and that's of face groups. Now, DSM doesn't have a face group tab, but nonetheless there still is an ability to remember face selections. So this is not going to be an in-depth tutorial, but I just want to quickly show it to you, and perhaps you can use it in your designs. If I select a face and now click select another face and another face, if I can now move those faces as a group, I can now make a little move like this. That's super. If I want to make a change, let's say, well, actually, let's just do something else right now. Let's click this hole and let's move the hole. So that's gone over there. That's great. But let's go back to this face. Now, if I click this face, I get a move tool. But if I click it again, it actually remembers that those three faces moved in unison before. So they're available again to move as unison. And what's also clever is that whilst I can move one again, if I now click one and click again, just hover slightly to the right, to the left and click again I get three. So that's clever. It's also clever that if I click this one and go to the right of it again, I get a pre-selection of its group. So it's remembering its group in any clicked member of the group and at any time, because I can go back here, I can move this face, which has a mirror linking, as you can see, and I can now go back here and it will come. Sorry, so I've moved one, but I can also now move the three, which is very handy. There's no structure browser marking or symbols to record these informal face selections, and remarkably, these remembered groups are still available upon file reopening. Now, for a better example, for instance, over here, you can see if I touch once, I get that, but if I touch again, you can see I've actually got the whole of that tang ready to be moved, and I think that is very convenient. Now, this model may look relatively simple, like there's not much going on, but if you look at the structure browser over here, and I turn all the structure browser off first and then on, you can see it's quite complex in terms of I have many annotations and I have many axis lines and I have many annotation planes, and basically it's all very messy and all a little bit confusing. So with the next version, sorry, not the next version, but the current version 5, custom views were introduced. That's a directional view of pre-selected objects with options to update it or not with any additional newly created object. You can set these things up quite easily, and here you will notice that if I just click on my front view, all the view is just the solid and one annotation plane. It's also got an axis in as well. But let's have a look at my top view, which shows just the solid again with two annotation labels and a couple of lines, which are layout lines on a pin geometry associated midplane. So they follow a related geometry face move, and they can have a thickness, but the dot dash style shown is only available with the drawing module. There are other views. For instance, I have a right lateral tang, which shows me that. So if I want that information about changing the tang, it's all there, including my little axis. So why the axis line? Well, firstly, it's been pinned, so it keeps to the virtual intersection of the inner bend faces. And secondly, unlike a bend center line, it's much easier to catch, and a good reference for move and pull operations. Whilst we're talking about these views, these special views that I've got here, these views can also be taken into the drawing module. So here within the drawing module, here is my drawing sheet for the contact strip. This, as you can see, this is my new view here. If I select this view, you will see there are certain properties down here as well. Have a look, please. Now then, we were talking about by contact. Now I know that the by contact really referred to this tang information over here, this angle between the bend of the tang. But what I'm really after, even though it's the by contact view, I'm actually after this small front tang information. So if I left click that, right click show dimension, up comes all the annotations for that. Now, everything isn't perfect. If, for instance, I try to box select this tang here, let's do a move, and let's give it an orientation to move. If I click this, now normally if this was a dimension which was actually added to the drawing, you'd get a little spark dimension. But I don't, in this particular case, spark dimension isn't there, but you just move it, and fundamentally you get a reference value for the increase, or you get the total distance. Clearly you can see one on the left has also gone up, which is great. Please, when you're doing this, actually note these phantom move tools. Pretty handy. For instance, when we did, let's do an undo here. When I actually box selected that, you don't know, there's always a possibility that it's actually picked something up on the other side of the model. So wherever you get this phantom move tool, it gives an indication as to the extents of what has actually been captured. The move tool will always go to the middle of the extents of the captured objects, be it faces or solids or anything like that. So I just want to quickly show you some additional information to correct a capture that I took previously on the top of this tang. It wasn't aligned correctly. Let's now capture the top. If I spin the model around, you can see, as I said previously, that move tool has gone to the middle of the extents of all the objects that it's captured. Previously I made an alignment with this edge, and that produced a slightly skewed move tool, although it wasn't important for the move. However, if we now move this and move it to the top face, you can see it orientate more in line with the, let's say, the directions of the face. It's actually the UV face directions, but let's not get into too much of that. If I go to my home view, you can now see that the tools, the phantom tools, are now actually positioned as you might expect. So another interesting thing just quickly is that you don't have to choose this particular move tool to move. If I chose that direction up there, that direction now becomes more solid with the other ones moving into a phantom mode. I can right click on this and still choose the ruler dimension. And the interesting thing is that I can now select any point on an edge. For instance, there's a midpoint, an end point. So let's go to the end anyway. And you can see I've got a dimension 7.66, sounds a bit strange. But in any view, I can now select that dimension and I can, let's call it 8, for instance. That's a nice number. And there it changes to 8. So I just really wanted to show you that ability. I think it's primarily there, so you can in fact move 3D models in 2D view sets. So this might be of use in an assembly view where you've got sections and you want to move things relative to parts within complex assemblies. And such as this view here, it's a section, so you can reference things even though they're not displayed on the outside edges. Now, even in the drawing sheet, and you've probably seen this many times in other videos, what we've got, of course, is by twisting the model, you can effectively see, if you like, 4 views representing the 2D views in particular directions. But nonetheless, we can still design in this if you wanted to. And also, the labels would be associative. So, for instance, if I can just get to the bottom here, and let's just move that face, you can see that that face is highlighted. We have a spark dimension here, and let's just make that 5.5. And because there's a mirror association, I'll show that on the model, that face has gone as well. So let me just undo that. Now, by adding dimension labels, not only are the necessary part sizes with tolerances being annotated to the drawing, but any part tidy up to improve or change the size, perhaps to preferred numbers or even rounding, etc., is easily achieved by face selection, direction setting, and label change value. So this is totally irrespective of how the model was originally created, and it's a very useful technique to focus on the view and local detail using label dimensions to modify the model to the preferred drawing dimension size. So here in the section, manufacturing and inspection additional helper or reference label dimensions may be used even though they're to either theoretical face intersections or even just between the 2D circles. Now, going back to the model, let me show you again what we were talking about earlier. So I can just box select that. Let's give it an orientation and let's move it. It doesn't need to be moving because all I need is the direction. And then I get myself a spark dimension and I can type in a value. But what I want to do is just show you basically that all 4 move in one time. It's a little bit not very edifying, but there you can see it all going. Let's undo. Now, coming back to face selection memory, if we click a face and then double click, we've got all these remembered faces. If I give a direction, I can now change on a value, and I've got a value here of 14.6 across the reflected axes. 14.6. So let's make that into around 15. No, let's make that into around 16. That's great. Let's just now say, well, okay, how about the angle? Well, unfortunately, with this set of faces, I've included the bend radii, and a change of angle won't be allowed. So doing a right to left box, selecting everything touched. And with them selected, put the Move tool onto the pinned axis. And by selecting the rotary Z axis, I can now change the spark angle dimension to, let's say, 90. And there you have it. Let's now look at the assembly. The assembly is quite important, but I just wanted to show you what can be included in the assembly. I have 2 components within the assembly, and these components are external, which means that I only really get a certain amount of information that comes into these components. Everything's available. I can always right click, and if they weren't open, I could open the component and I would end up with this view, giving access to the drawing, any selection memory, and model custom views. In this particular case, it hasn't got the full memory of the face selection groups. However, I can still do lots of things. So for instance, if I group select, and let's say I can add, and I can go to the other side and add, it still remembers that we've got 4 tangs associated, and I can pull these tangs and all of the tangs go together. That's great. I can, same over here really. Let's just make this the active part. Now it's active, which means effectively that I can't pull on other faces that are grayed out, which is fine. So let's just do a box selection. And here you see a box selection of that tang. That's good. And again, the mirror plane and also the graying or the texturing of the related linked faces shows up. So I can pull this and I get a duplicate change, which is nice. Let's now make that the active part, which is this other part, which is called plate. So what's happening on the plate? Oh, look, so I got this hole. These can move as a pair, and that can move as a pair. That's okay. And let's move this just as an example, just by a small amount. So that's okay. Now look, if I now hit my body interference, you'll see we have some red areas showing a body clash. Always check to see that those aren't there. Let's now correct that. So how do we do this? So you would select the surface. You wouldn't need to set any direction. If you just now go U for up to, you see this comes to light. I can now select any cylindrical surface and it will jump to it. So for instance, I can select this here, or I can select the edge. So let's select the edge, and you'll see it jumps back, and you'll see across, reflected across the mirror plane, that's jumped as well. So that's fine. So let's just double check. Let's have a quick look. And although a solid shaded view is highly visual for shape appreciation, it can also alter easily obscure misaligning holes. So let's go back to this view and let's now move these holes to line up with there. See what happens. So let's select one. Okay. I've only got one here. So again, let's go up to and move the cursor over the target object. Press Control and rotate the middle mouse wheel, and you can see it drives through, and that's fine. So if I now select that, that's jumped to it, and that's jumped to it. So let's go back to our previous top view, and as you can see, everything now lines up. In the assembly view now, there are some additional components. Each of these components has been made in the context of the assembly, and each of these is also mirror symmetric. So if I select two faces and I pull by quantifying an amount, you can see that both instances of the part change. Let's undo. And it's the same with these little, I've actually called these a connector tab. I touch on here, again you can see the mirror plane. Let's select another side. So we have two plane symmetry here. And if I want to put a value in, let's say at the moment we've got a 0.7 width, so let's change that to 1. In fact, let's just take that off. So let's now change, sorry, wrong way. Let's change that now to 1. And all 4 has changed. And clearly as well, if you just do a pull on one surface, they would all go up as well. Now, although we've got this assembly is consisting of 3 or 4 parts, what you can also do, even though the mirror functionality is still there within all these separate components. If I now, let's have a look. So top part is active, which means I can pull on all the faces, but I can also move as well. So let me just now do a selection, lasso selection. Okay, if I can now place my move tool, place the direction. Note that in each of the parts which is available for a mirror operation, we get two mirror planes, and of course you get the texturing as well to confirm. Let's now put a value in, and what I'm going to do, I'm going to use a local face, and let's make that now 1.5. There you see the change on both sides. Going back to this component, I don't actually have my multiple face selection. So if I just quickly go to the open component, now you can see if I click this once and once again, I've got all the tabs that can be moved as one. If I now click this, click this, and this, I've just cycled through all the available selection memories associated with that face. So by just setting a direction, I can move my spark dimension, and this is really quite clever because this spark dimension here is actually tangent over the inside bends. Let's make that 4.5, and that's changed. Nice. Go to the assembly and you will have seen that that's changed as well. So there's many opportunities to do efficient changes with symmetrical parts, and although this particular arrangement is obviously set up to demonstrate the functionality, I think in general practice, in general engineering, there's a lot of symmetrical shapes, be it sheet metal, printed circuit boards, any component. All manufacturers really would like is not an asymmetrical shape, but a symmetrical shape. So I hope this demonstration of the available technology may help you in your designs.